Welcome. I'm Judy Furlong, a distinguished engineer at Dell EMC and co-chair of the OASIS KMIP Technical Committee. Today, Tony Cox, my co-chair, and I will provide you an overview of KMIP and specifically looking at what is new with our 2.0 release. First, a couple of logistical points. Today's session is being recorded. Both the recording and the presentation materials will be made available to those of you who are attending and will be on the OASIS site. In addition, if you have questions during the presentation, please feel free to enter them into the chat window. We will be taking questions at the end of the presentation for as many as we can cover, and any additional ones we do not cover, we'll get back to you separately. So with that, welcome. I'd like to go to the next slide. So first, what is this Key Management Interoperability Protocol? It is one of the OASIS standards. It is specifically focused on ensuring that we have interoperability between products that encrypt information or need to protect secret information, and the back-end enterprise key managers that actually manage that information. So this is so that we have a full lifecycle capabilities to protect both keys, credentials, and secret materials that may be relevant within your infrastructure. Through KMIP itself, the protocol itself consists of three primary elements. Operations, which are the actions that are performed on a set of managed objects, where objects are things such as keys, secrets, and passwords. And they are described by attributes, which you can think of as metadata around those information. The protocol itself is a set of messages that actually that is exchanged over a mutually authenticated TLS channel to provide an underlying secure communication channel. Go ahead. Next slide, please. The key management, our particular technical committee produces 4 documents, 2 of which are normative and go the OASIS track standards. One of which is the actual specification of the protocol. And then the second is profiles, which are essentially a view or profile of the set of functionality that you may find in the specification that are applicable to specific use cases or applications. For example, we have profiles for self-encrypting drives and how you would manage them. So there's a number of basically making it easier for implementation and for common capabilities to understand which of the operations, attributes, and capabilities that are relevant to your environment. There are also 2 informative documents, one of which is test cases. Those are essentially, and we'll speak about those a little bit more, but those are basically how, if you're implementing our KMIP protocol, the common ways for you to easily test using these standard test cases to see if your implementation is conformant and doing as you expected. And then lastly is the usage guide. This is a document that provides additional information around particular scenarios related to the various functionality that's in the specification. And it also has a detailed section on how you can use KMIP to solve additional use cases and capabilities that may be relevant in your environment. So this is kind of more best practices and guidance. You can go ahead. So what does it do? We've talked about this. It is essentially a client and server protocol that sits between, obviously, the clients are embedded within applications of clients, etc. Capabilities or products that are encryption aware and want to have their key material, secrets, etc. managed by an external key server. The It is usually the client that initiates the communication channel with the server for the majority of the functionality. So this is a request response protocol. However, there are a couple of functionality, notify and put, where the server can actually communicate and initiate the communication out to the clients. But, so what do we do with this? And so the advantage of the KMIP protocol is that you have a single methodology that a variety of different applications from a variety of different vendors are able to communicate using this single mechanism. And this allows you to consolidate the security management and of both keys and associated cryptographic materials in a common key enterprise key manager. So this one in customer environment may incorporate a single key server that's able to support all our encryption capable aware products in that environment. These could be application level, they could be databases, they could be functional infrastructure components such as storage or servers, all within the one server. And this solved many problems that we had in the past where everybody who was speaking different proprietary protocols were able to consolidate this down into a single environment. But it's actually more than just creating, registering, and retrieving encryption keys and security objects. There is a lot of additional services. For example, you are actually able to offload to a server cryptographic functions such as encrypt, decrypt, signing, or split keys. This is very useful functionality, especially if we're looking at some of the IoT devices these days where you may have limited functionality within said device. It may not have the ability to do significant amount of processing. So having that ability to offload some of the functionality you might want to a central server is of value. In addition, some of the metadata around the cryptographic key material helps you actually manage and understand. For example, you can attest what may be the environment in which a client is living. Is it FIPS compliant, for example? So that allows the server to determine whether it actually wants to release certain key material down to that actual device, or if it has to do it in a way that's actually encrypted or wrapped, because that's a requirement for a certain level of FIPS 140, for example. So this is basically gives us a lot of extensibility to do full key lifecycle management within and support a wide range of products. You can go ahead. So the actual KMIP technical committee was started 10 years ago in 2009, which was originally an effort that was 4 companies had come together, both the storage and security key management vendors were the initiators of this, and we brought this into the OASIS community. Over the last 10 years, a number of different organizations from representing a variety of different users and industries have joined the technical committee, and the spec itself has evolved over a number of years. So we are the current published version is 1.4, which was actually issued last year. But what we have been significantly, and what the remaining portion of this presentation is about, is our effort to do a 2.0 version of KMIP. And one of the advantages of KMIP of the 2.0 release is it gave us an opportunity to actually do a major significant rejuvenation of the actual specification and functionality. So while we continue to maintain some of the existing and well-used functionality, it gave us an opportunity to remove functionality that, while at the time that was a good idea when we were originally putting it in, we found in practice it wasn't actually being used. So this gave us plenty of opportunity to be able to remove certain unused functionality from the spec. It also gave us an opportunity to changed the spec in a way that it's actually much more easy to read and consume, especially if you haven't been involved with the 10 years of development activity. It makes it much easier for somebody new to this, new to the TC, to be able to quickly come up to speed and implement the actual protocol and capabilities. So Tony will certainly cover a lot more around the details of what's new in 2.0. And we'll give you an update at the end as to where we are in that process of getting the 2.0 to OASIS standard level. Go ahead, please. So KMIP itself is a number of, as I mentioned, organizations are now reliant upon KMIP to manage both their keys and their secret objects. This is one of many, this is a number of, obviously, vendors, both participants within the technical committee, as well as other users of the technology. It is a good representative list of who is using it. And more importantly, you go ahead, that's fine. And more importantly, while we started, like I said, in a storage-centric world, we have quickly evolved this to to support a number of cloud-based applications, IoT devices in a number of different form factors, connected cars, for example, an automotive industry, medical devices, and a whole host of other functionality that is now widely used. So with this, I will turn it over to my co-chair, Tony Cox from Cryptsoft, who will take you through the new functionality in 2.0.
Thanks, Judy. G'day, folks. My name's Tony Cox. I'm VP Partners, Alliances and Standards at Cryptsoft. As Judy mentioned, we have a range of new content sitting in KMIP 2.0. For those who've been around with the standard for a while, there is a fairly major redesign of the document itself, the specification document, to make things a little easier to find and for ongoing maintenance. So that's a very large, obvious change. As far as the content goes, I've captured the majority of it here. There's a whole lot more detail naturally sitting behind this and a whole lot more concepts down at the very detailed level that I'm not going to get into today. We simply don't have the time. But essentially, we're looking at a range of new features being added in. They're either new objects, attributes, or operations, or a mixture of those, as well as some of the other structures. And we've also got some improvements to the way in which we improvements to the way in which we handle the specification and the way in which material is managed within a KMIP system. Thank you, Dee. Next slide. Thank you. Okay, so we'll start with client provisioning. It is a sore point for a lot of implementers in terms of what's required to go through and provision a client. Over the various versions, we have made improvements to the way in which that's done. What we have done within 2.0 is put in a range of changes that are mandatory for use within 2.0. What that has done is streamlined the registration process. We're using a range of methods to do that, use of PKCS12s, passwords, etc. Basically provided a more predictable and more efficient way of doing it, such that clients can be spun up far more quickly for use in automated environments such as virtualized environments for cloud, etc. And when dealing with very large scale environments. Whilst we were messing around with client provisioning, we also noted that the credentials used by a client do have a life cycle, and we may wish to turn over the credentials used by a client. So we've provided an efficient process whereby a non-expired client credential set can be re-provisioned by the server. So effectively turn over those credentials, issue them with a new lifecycle, a new set of operations, etc. Again, improving the security posture for KMIP. Hash passwords. Whilst KMIP, as Judy mentioned, requires use of a mutually authenticated TLS session, hence everything flowing across that is encrypted, passwords are transmitted outside of that pipe in the clear. And that causes some problems with some implementations who require that not to be the case, particularly in higher security environments. So we've simply defined a standardized hashing scheme to ensure that we can predictably encrypt those passwords for use as they're transmitted across, and then also within each of the environments. Next slide. Okay, adjust attribute and set attribute. For a good many implementations that exist today, the attribute stored against a given managed object, there is only one attribute. There is a very rich methodology for storing. You can store an unlimited number of attributes in nested form for a variety of different object types. But despite the richness and capability involved in the spec, there are a good many implementations that only store one attribute, used generally to locate that cryptographic object in the management system. When you're doing a change to an attribute, it would normally involve a couple of round trips to locate the object, locate its attribute, and then remove that and put in a new one. What we've done is simply allowed a mechanism to say, if there's only one attribute, just change it to this, please. Again, improving the performance, reducing the message size and the backwards and forwards between the client. The same applies to set attribute. When you're dealing with a newly created or updated object and you wish to simply set one attribute, we've provided a much smaller, more efficient message to do that, such that a single attribute can be placed very quickly without the overhead required for a full attribute set to be stored against that object. New algorithms. We have put in a fair bit of time and capability into certainly 1.4 and then again in 2.0 in looking at the post-quantum world in terms of how we define the roadmap for that once we start seeing real threats in the market. Given that we don't know which algorithms are going to be vulnerable yet, we have a fairly reasonable suspicion, but nothing is proven. Rather than try and pick which algorithm is going to be safe, we have simply provided a framework by which a key management system can define, okay, these are the key types algorithms that are at risk. I need to change from those to something else. So in doing that, we need to have those something else's available. So we're adding new algorithms for post-quantum. We still have a range to add in 2.1 once the NIST process completes, but we've got to start somewhere. We've also added a range of new algorithms to deal with some of the national ciphers where we've got deployments sitting in those places and people needed a interoperable manner or interoperable methodology to handle those ciphers within a key management system. Next slide, please. Okay, login and delegated login. So within the KMIP system, if a client connects to the server using its standard issued credentials, then it is considered logged in. Within the KMIP 2.0 specification, we elected to have the capability for a server or a client to log in. So effectively, the server will issue them a ticket. And what that allows us to do is set a time limit on that login, an operational limit in terms of what it's able to do, number of operations, types of operations, etc. So effectively usage limiters, and naturally there is a corresponding logout operation to go with that. Once we'd explored the concept of a ticket or a login ticket within KMIP, we then went into delegated login. So with a client logged in with a set of rights and privileges to interact with objects in a key management system, we then wanted the ability to have that client authorize other clients to do certain work. So effectively, all of the rights that a client is logged in with can be delegated to another client, but more importantly, a subset of those rights can be allocated. So for instance, in a highly automated environment, if you wanted to fire up a client whose job it was to fire up other clients or just create objects or just remove objects, you could effectively say, right, set up another client, I'll delegate some rights, I only want you creating 100 objects, and then you can log out, and that's your limit expired. So in a very large scale environment, again, coming back to virtualization and IoT, where you've got very large volumes of clients needing to be ramped up very quickly, that allows that to happen. It also allows two-factor authentication to be rolled in as well. So again, broadening the capability, so the applicability of KMIP as well as its deployment at scale. and automation. Okay, one-time passwords or passphrases. We had many vendors in the market using OTP within a KMIP system. It's fairly natural to do so. But in a lot of cases, what was happening was they were being set as a vendor proprietary manner. So we needed to standardize that. So we have effectively treated OTP as a credential. We've inserted it as a credential type, which allows us to use that for two-factor authentication and more granular authentication for clients as we layer up the various authentication capabilities. Next slide, please. Okay. We've gone forward a few there, Dee. Can you back up one or two slides? There we are. AWS signatures is what I'm looking for. Back up one more. There we are. Okay, so within AWS signatures, we acknowledge that that there are folks using the Amazon environment. It's pretty hard not to. What we have done is taken the version 4 of the Amazon signature scheme and added that as another derivation method. It is simply a key derivation method, and that allows us to assist those folks deploying KMIP into an environment that needs to touch the Amazon environment. So again, increasing the applicability and interoperability for key management systems. Certificate signing requests. Previously, we did have the ability to perform signing operations, verify operations, a whole range of cryptographic operations that Judy mentioned earlier. Simply, we needed to add a certificate signing request or CSR as a managed object, so that can be handled and utilized within the system, both for setting up clients and for other purposes where required. So again, increasing the performance and applicability for KMIP, and certainly improving the predictability that's useful in autonomy, particularly at large scale. With key format type, up in the 1X series, we never actually specified a default key format type when you were creating an object or using an object. That leads to some interoperability challenges. So effectively what we have done is defined a set of defaults for key formats as they're created within the system, which provides deterministic behavior, leads to better performance, better autonomy, and also provides you with the ability to locate by key format, which is quite powerful when you're looking for particular key types in a key management environment. Next slide, please. Okay, full ASIC. Within the KMIP environment, we have the ability for a server to respond to incoming client requests in synchronous mode or asynchronous mode. In asynchronous mode, an asynchronous correlation value is applied to each request coming in, either in singly or in a batch from a client. What we have done here is put in a request for the client to specify to the server that I don't care whether you're processing my request synchronously or asynchronously, I want my asynchronous correlation value. So effectively forcing the server into async mode. What that means is we get better predictability and better performance in terms of when we want to batch up very large operations. It simply means that we have increased interoperability and better performance at scale. Flow control. So back in the 1X series, we implemented a very limited set of client to server operations. Now, KMIP being server to client operations. KMIP being a client to server protocol, this effectively flips it on its head. So we've had the ability to perform a very limited number of operations. It started out as just 2, which was put and notify. So the server saying to a client, here's your new key, and notify, please start using that new key. And that was designed for some very specific environments where you've got limited capability on the client side. But what we figured out was we had no real way to define how that was going to happen. It required an out-of-band connection. So again, we saw some interoperability challenges in the market with folks trying to do that and not having the same result in each implementation. So we just standardized it. So we have the ability for an incoming client here to request the server turn that connection on its head. So within one network connection, you form the network connection between the client and the server, and then you can tell the server, I'm going to sit in receive mode, and the server is going to send me requests. That is very useful when you start thinking about remote client management, and particularly in IoT and large volume applications where you might set up a couple of clients, one in listening mode, one in sending mode, or in fact just turn that connection on its head multiple times. And then you start combining that with delegated login and some other stuff, and you start to see a very granular, very capable system. Multiple ID placeholders. We're now getting down into the minutiae of a KMIP system. Within a KMIP system, you can do a locate on multiple items. They will get an internal ID placeholder. What we've effectively done is said, can you please hang on to those so that I can come back and perform another operation on what you've located for me. Not, very, very simple solution to a multiple round trip problem. So again, improving the efficiency of the messaging and enhancing the automation for larger deployments. Next slide, please. Okay, PKCS 11. So within a key management environment, it's very hard to do any form of key management without bumping into the PKCS series, in particular PKCS 11. And we have a range of deployments out there in the market which back onto other systems that use PKCS 11 for transacting, for performing cryptographic operations. The issue there is, whilst the PKCS 11 APIs are well defined and standardized, the method of transmission across the network is not. So what we've effectively done is encapsulated PKCS 11 APIs within the KMIP protocol, so allow that encapsulation such that it can be transported across the network. What that enables us to do is sit into a much wider security environment, usually bumping into things like HSMs and other devices, tokens that provide or that utilize PKCS 11. And use the full cryptographic operation set that sits within KMIP, so that you could effectively come in across KMIP in one channel or PKCS 11 in another, and have a standardized protocol in between. What this does is widens the applicability of KMIP, particularly in a range of high security environments, and allows us to integrate with a much wider ecosystem of deployed security devices out there in the market. Okay, we have an interop operation sitting within KMIP 2.0, not designed for use in production environments. What we've designed this for is effectively for interop testing. I'll get into the testing a little bit further down in the presentation, but we do an awful lot of interoperability testing within the community, be that within the standards community itself, within the KMIP TC, and also out in the market on occasion. And that is how we know this protocol is actually interoperable and does actually work across multiple vendors. But what that requires is people to understand what exactly they're testing. So the interop operation allows a client to say, right, I'm going to run an interop operation, and it's going to be this test case, and then at the end of that saying, right, I've finished with that test case now. What that does is simply allows a server to understand what's coming in, so that it can say, right, well, you're running that test case, I know what I'm looking for. And particularly when you start going back and having a look at the logs to make sure that what was run successfully and does match the test case, makes that an awful lot easier. And given the sheer volume of testing that we do within the TC, that streamlines that operation. Not particularly useful in production environments, but the result of that production, that testing is useful out there in the market. Re-encrypt. We have introduced the concept of re-encrypt within KMIP 2.0. We've done that in a fairly elegant manner. Basically, we're using an indicator on a decrypt and then a following encrypt to mark it as ephemeral, effectively. So providing a client would request a server to decrypt a payload, it would set the ephemeral marker to true. The server will then hang on to that payload and then wait for an incoming encrypt. So effectively what that means is you can do a decrypt and encrypt within the server environment without that encrypted data flowing out across the wire in free text. It actually keeps that within the security boundary of the server, which From a security perspective, gives us a lot more capability, and certainly from applicability, automation, and performance perspective, gives us a lot more capability within the specification. Next slide, please. Okay, we're down into the improvements. So canonical attributes. Whilst the KMIP specification was very clear in terms of dealing with attributes when you're setting them or modifying them or retrieving them, you would specify the attributes in their full text form. So effectively a text string identifying which kind of attributes. We have a structure in KMIP to reference those in canonical form, but given the compromises we made across the 1X series as we were getting established, they weren't being used. So what we've done in 2.0 is moved everyone across and said, right, you're now going to use canonical attribute or canonical form for expressing and dealing with attributes, and that shortens the message size considerably, which naturally enhances the way it works from a performance and scalability perspective. From custom attributes, we do have we've had the ability for a client and a server to deal with customized attributes that are not handled within the spec. In other words, a vendor might want to handle a particular attribute in a particular way, and they had a methodology for doing that. And whilst that was great within that customer's environment, if you're dealing in a heterogeneous environment, you might bump into the same vendor extension use within a custom attribute, and then naturally you get confused because one vendor will express one thing, calling it one thing, and the same thing called differently by another vendor, or the worst scenario, they're called the same thing for completely different attributes. So what we've done is constructed a method by which we append some information about the vendor into that, such that we never bump into those, and we have a standardized way of dealing with non-standard information in an attribute form. So again, trying to clear up some of the interoperability things that we're finding out there in the market. And standardized vendor extensions. So effectively requires a vendor to put more detail into the vendor extensions they're using, such that we know exactly what we're dealing with. Again, aids in automation because we can predict what's going on. We've got a much clearer idea of what's sitting inside those standardized vendor extensions, without necessarily getting involved in specifying how they are to be used. So again, just trying to increase the interoperability within the market. Next slide, please. Okay, default cryptographic parameters. Again, we had cryptographic parameters stored within KMIP. We've got a very rich set, but we didn't set any defaults. We left that up to the server implementers, which again started leading to inconsistent behavior as folks implement their own systems. So what we've done is within KMIP 2.0 specified the default parameters that are to be used there. That's cleaning up another corner of interoperability issues, as well as providing improvements for performance and scalability, given we have a far more predictable system. Okay, cryptographic usage mask. This did exist in the 1X series, but was not well used and was not very well expressed. So what we've done is cleaned that up in terms of making it much more clearer, adding another layer of specificity, and again, better predictability means better performance and automation at scale. Okay, additional result reasons. We did have a set of, they're effectively error codes within the system. We did have a set from 1.0, and we have been adding to those as we went on. But in a lot of cases, as many of you will attest, error codes are generally left as the last thing to be worried about. So sometimes they weren't as clear as they needed to be, and we certainly didn't have the rich set required to run at very large volumes and actually get repeatable errors out or understandable errors that aided in solving issues. So we've added a much larger set of response codes that enable better troubleshooting. So again, helping us with automation and scale, which has been a large focus for the TC. Next slide, please. Okay, direct logging. So this is effectively a very small change to allow a client to insert a log entry onto a server. Not really a whole lot of detail needed there, but simply the ability for a client to say, right, can you please log this? And that is very, very useful in an automated environment, and particularly when you're dealing with troubleshooting a system where you might have some strange errors and you want to append something in the log saying, I think it's going on about here, put a marker in the log. Again, increases the supportability of KMIP and allows us to deal with automation issues a lot faster as well. Okay, within the 1X series of KMIP, we have a destroy operation, but destroy was simply destroyed, and that can be interpreted a range of ways, which, when you have interpretation, naturally leads to potential interoperability issues. So what we've done is define what it means to destroy something within KMIP in terms of its impact on the object itself and its attributes. Again, helping with predictability, automation, speed, performance, etc. Okay, mandatory authentication. Within the 1X series, there were a very limited number of operations that a client could perform against a server without needing to authenticate, mainly retrieving information about the server and the environment in which the server was able to operate. We've said, well, nobody's using that. We may as well just require mandatory authentication for everything. So again, breeding better interoperability and performance. TLS changes. So with the advent of TLS 1.3, we've basically said that for KMIP 2.0, bare minimum is utilizing TLS 1.2 for the incoming connection between client and server, and we would recommend TLS 1.3. Next slide, please. Oops, there we go. Okay, fine-grained timestamping. When you start dealing with multi-node clusters and replication between those instances, between those nodes, the timestamping we had at the second level just wasn't good enough in terms of dealing with potential clashes in that environment. So effectively what we've done is introduced a secondary timestamp for operations occurring within the, events occurring within a key management system. We're down to the microsecond at this stage, which, you know, how far do you want to go down that path? We figured microsecond was good enough in most cases. So we've added that capability in 2.0. We've also added some capability into the locate operation. That is a very well-used operation within KMIP. It means you don't necessarily need to store the UUID associated with a particular object. You can store something else that would allow you to retrieve that, you know, something associated with the data it's encrypting, for instance, as metadata. What we have done is changed the way that locate works, or at least improved the way locate works in 2.0 to give more predictability, but certainly in the way that results come out. So when you're dealing with a large set of results, different vendors had different views on the order in which those results should be presented. What we've done is standardized on that, such that you know what's coming, you know the order it's in, and you can, again, breeds more predictable behavior. Attribute index removal. Effectively, this was an overhead that carried over from 1.0. We've decided to remove it in 2.0. You could use an attribute index when you were dealing with particular attributes. There was no need. So particularly when we're dealing with canonical form was the other change in 2.0 that I mentioned earlier. It's just not needed. So we've removed that, which again reduces the message size and complexity, which breeds performance and scalability enhancements. And key value location, simply a method by which we can determine that the object, the key material, isn't necessarily in the key management server you're talking to. It might be somewhere else, for instance, in an HSM, which naturally breeds improvements for security, particularly in regulatory environments. Next slide, please. Okay, so in terms of how that all works within the KMIP Technical Committee, we have a fairly robust development process. Basically, we'll be taking in enterprise requirements from the market. That feeds into the specification development. That then is very well tested before we release a version of the specification. That goes into products, and then we see that coming around again. I'll come back to this slide in a moment. Next slide, please. Okay, for that to all work, we actually need testing to happen. Over the last couple of years, we've been doing one annual interoperability test. as effectively a qualifier to turning up at an OASIS booth at the RSA conference in San Francisco each year. This is conducted between members of the technical committee. In this case, we had 8 TC members participating. From those 8 members, we had 13 implementations, 7 were clients, 6 were servers. And over the 2 weeks that we did the interoperability testing, which was focused just on KMIP 2.0, we ran approximately 56,000 successful test runs. Now, in a lot of cases, we've got many of those vendors tweaking products for the new capability. So if you actually go back and have a look at the volume of tests conducted during that test, we were well up over 120, 130,000 individual test runs, just as folks retested items. So I had the pleasure of coordinating this test, wonderful group of vendors to work with. So what we're seeing a lot of test runs over the multiple encodings, because naturally KMIP is specified in TTLV, but as optional encodings, we also cover posting over HTTPS, JSON, and XML. But again, the volume of testing enables us to very confidently say that this works across vendors, meaning that implementers and consumers of this technology can quite reliably run KMIP systems in a heterogeneous environment. So, you know, I'll grab my tape library from this vendor, I'll grab my disk array from this vendor, I'll use this cloud service, and I'll use this key management server, all from different vendors, knowing full well that it will work together. Next slide, please. Okay, so we are, in terms of where we are with the specification at the moment, we have just wrapped up the specification and profiles, the normative documents for 2.0 as committee spec draft, and they are going out for public review in the next couple of weeks. Certainly the normative documents are. We already commenced work on version 2.1. We had a face-to-face meeting just before the RSA conference back in late February. So we've already started setting the scope for KMIP version 2.1, and we will likely be testing that later in the year. Assuming we have a successful public comment period with no major or material changes to the spec, we'll push straight into committee specification for the specification profiles, whilst work is continuing on 2.1. And from there, the KMIP 2.0 spec will go into candidate OASIS standard, then hopefully published by OASIS very, very shortly. And the TC has also decided to submit the KMIP 2.0 spec and profiles into the ISO process to become an ISO standard for those countries that require it for deployment into government and related systems. So that's on the roadmap as well. Next slide, please. Which leads me back here. So for those who have joined today's webinar who are not members of OASIS or members of the KMIP Technical Committee, if you are bumping into KMIP in the environment or you have requirements, things that you think the KMIP specification should be covering or covering in a better fashion, we would welcome those requirements. There are multiple ways to do that. You can post an email to the KMIP comments list, which we are obliged as a TC to respond to, and that email address is available from the KMIP TC homepage. But we'd also like you to get involved, which means joining OASIS if you're not members already, and from there joining the technical committee. We only exist due to the efforts put in by the various members, and the more folks we have on board in the TC, the better requirements we're going to get. We're going to get wider applicability. So I would certainly encourage you to consider joining OASIS if you're not already a member, and joining the TC if you already are. Next slide, please. And for those companies who have joined, I've just grabbed a very quick sample of the current membership. This is the current active membership. If we look at the wider membership of folks who are keeping an eye on it but not necessarily participating over the years, that is a much longer list, but this will just give you a snapshot of who's participating at this point in time. Next slide, please. Okay, and with that we are finished. So if you have any further questions about the presentation itself, please feel free to contact Judy or myself. We'll be happy to answer questions in terms of what's going on in KMIP 2.0. If you've got any of those questions, there's a link there to the KMIP TC homepage. I'd encourage you to go there and have a look. That will certainly provide you with the information required to contact the technical committee. And naturally, for OASIS membership, you have a link there to contact the OASIS folks, including Dee, who has been facilitating today's session. So thank you all for coming along. We would appreciate any questions or comments you might have about the work that we're doing within KMIP, and certainly any inquiries that you have about joining OASIS going forward. Thank you for your time, folks.
Great job, Judy and Tony. Thank you so much.
Thanks, Dee.
Good day, folks.